Hello, good morning, good afternoon, or good evening, everybody, depending where you're zooming in from. And welcome to the Hyperledger Foundation in-depth webinar with Splunk on observability and blockchain, a deep dive into Fabric and Besu. We are delighted to share with you this next Hyperledger in-depth webinar, and we're very excited about today's presentation. My name is Tomasz Sedej, and I'm an ecosystem manager at the Hyperledger Foundation. Today, I will have a chance to introduce our panelist, Antoine, and also take you through some housekeeping rules. So if you ever joined our webinars before, you know that we have some housekeeping. First, all are welcome in our global community, and we are committed to creating a safe and welcoming environment for all. So please follow the Hyperledger Code of Conduct when interacting with each other or talking with others in the community as well. You can find our Code of Conduct in our website and also on our wiki. All Hyperledger Foundation member webinars are held under the Linux Foundation Antitrust Policy, which you can find on our wiki and also on our event page on our website. We are recording this webinar, so you are also welcome to come back and check out our webinar library, where the recording will be available along with the slides. This webinar is also being live streamed on YouTube, so welcome everybody joining us there as well. Now, we encourage these sessions to be very interactive and engaging. So please stay active, and the more active everybody is, the better experience we will all have. So feel free to raise your hand, get unmuted, and speak up. If you would prefer not to speak up, you are also welcome to use the Q&A box to ask any questions you might have, or you can also put your questions in a chat, either here on the webinar or also on YouTube, and we will come to them as we go. If there are some questions that might not get answered since we ran out of time, you're also welcome to join us on our Discord channel and ask them there to get them answered. And I will share this information after the webinar. So without further ado, I'm very happy to introduce Antoine Toulme, who is a senior engineering manager at Splunk. And we really look forward to this talk. So Antoine, over to you.
Thanks, Tomasz. I'm going to share my, share my screen and take over. Thank you so much for introducing me. It's a pleasure to be here today and to talk to the Hyperledger Foundation members and on behalf of Splunk. And I hope that if you have questions, you'll stop me and ask questions throughout. Thomas is here checking the chat. Don't be shy.
Yes.
We will talk about observability and blockchain. And these are two different topics that are just coming together as they both mature. And it's really a privilege for me to kind of introduce you to observability if I may today. Hopefully you've been exposed before. So a little bit about me. I'm a senior engineering manager at Splunk. I've been at Splunk for over 2 years. Been working in blockchain. I'm also a contributor on the OpenTelemetry project, which I will talk about today. That's a bit of background. I'm based in San Jose, California. I'm active on the Hyperledger Discord. I'm a member of I'm actually a committer, sorry, of Hyperledger Besu, and I've been contributing lately to Fabric. So we have a lot of work in this hour because we will be talking about different things and trying to combine them. We will talk about observability, which is a mouthful, and I'll explain how to correctly pronounce it going forward so you can do it at home as well. We'll talk about the type of signals that observability contains, and then we'll go into OpenTelemetry and explain how this project is helpful for that purpose. We'll go to blockchain. We'll talk about multi-party computation and the different trade-offs that you have to make when you work with blockchain, and the aspects of distributed systems which are kind of amenable to observability and the different challenges that we see there. And so in terms of content, we're going to start with a primer on observability. We're going to talk about this application for blockchains, and we'll take a peek into the future. So first off, observability, referred to as well as O11Y or OLI if you don't have time. And OLI just rolls off the tongue, so it's much easier for people to use. I'll try to stick to observability today to keep it a little bit entertaining for you, so you can count how many times that I misname it. But yeah, OLI is how you would go about if you're at a conference and don't have time. Observability lets us understand the system from the outside by letting us ask questions about that system without knowing its inner workings. So this is a definition I picked up from the OpenTelemetry website. So it's interesting because it's allowing us now to know exactly what to expect out of a system without having to actually know its code, right? And it's a common interoperable standard to monitor software, to really debug and understand and make it transparent how it works. So we can have a common way to instrument the software, a common data model for all the data emitted by the software, and a set of common naming conventions and semantics. So we know exactly what to expect and what are the different names that we're going to be using. Good example is a host name would be set as host.name as an attribute inside observability. What's the question? Okay. So in terms of signals, right, if you're working with observability, you're going to have three big types of signals today, which are kind of mature, and maybe more will come later, but right now, these are good data points that we're able to monitor and track. The first type of signals, and we'll delve into that in just a moment, is metrics, which allow us to record different types of data points associated with a particular quantity or latency time or number of records, right? So for example, a max of an event would be recorded as a gauge that will allow you then to really see over time the discrete value of an event. You could also use a bucket style system to get a histogram where you'll be able to arrange a set of data points to make sense of them. Or you could also use an aggregation method that would give you the sum of a set of data points over a period of time, and then give you a sum. We also have the ability to record the execution of a particular program using a tracing system. A tracing system allows you to understand the different execution paths inside your program. Now, we're going to weigh on that quite a bit today. We're going to talk about how this plays out with blockchain, because obviously there's some use cases there which would span either one actor or multiple actors of a distributed system where you can trace those things. In this particular example, we are seeing three different web services which are communicating to each other and are using different execution paths that are correlated together according to the spans that form the trace. And finally, we have the good old log, the thing that everybody's been used to. You know, traditionally, in the origin of the term log is that you would take a piece of wood and throw it overboard to kind of measure the speed of your ship. And then you would record the data, meaning the speed of your ship in the logbook. When computer programs came to be, the logbook analogy got reused, and we started actually logging what was happening inside our programs using some explicit measurements, using some explicit messages. And so we'll talk about that, and we'll talk about what the evolution of that signal is over time. Now for metrics with OpenTelemetry now have a data model, which is now considered stable. It's been a long effort from the OpenTelemetry community. So here in that particular case, I'll just take you to this particular page here. And you can see in the OpenTelemetry.io website, there's a complete expose on those type of metrics. What is interesting here is to understand the different types of models. So here we have this high-level diagram that I showed you earlier for the different types of metrics. We also have the different types of mapping that we could see from different models of from the OpenTelemetry metric data stream to how it would be mapped to a time series, so you can make sense of it. So if it's monotonic and it's a sum, then it can become a counter. If it's non-monotonic, meaning it goes up and down, it can become a gauge. If it's a gauge, maps to gauge, histogram to histogram. There's a couple aggregation strategies that are very much custom to different types of metrics you might care about. So for example, you could see a sum being aggregated over a short period of time, and then you might see discrete data points there. Or you could just do an aggregation over the life cycle of your complete program. So for example, number of times someone tried to connect with you over peer-to-peer, that would become a total counter of everything that's been logged so far. And then interestingly, if you're looking with gauges, you can also have example of value in samples here, where you just sample the current value of that gauge over time, and a beautiful representation of a histogram where you could see like there's disparate values and events over a period of time, and you're going to aggregate them, but instead of just taking the sum of them, you're going to create a distribution of those values so you can make sense of them, so you can do advanced analytics based off that. There's one more, which is currently experimental. I'm discovering at this moment around exponential histogram, which is going to be able to create more recorded measurements in a compressed format. So I'm not sure we're going to talk about that quite yet. In terms of stability, this is the main types of data sets. What's interesting is this is now mapped to everything that you might be familiar with. If you worked with Prometheus, for example, there's some good conventions and guidelines to how this is mapped over to that model. You can see that right here in terms of compatibility and all that. So this is all coming together, and it's starting to kind of come in, make sense. And it's interesting because it was a whole lot of work from the OpenTelemetry community to come up with a model that was stable and that's now delivered as a $1 version of that. And similar to what you would see with Ethereum and others, there's a enhancement system where people can propose enhancements to the model, but it's highly codified and requires the community to kind of come together and adopt and ratify these changes. Now, traces. We talked about traces just earlier, and traces are built around the notion of a span, right? And they're made of multiple spans coming together, being assembled to create a complete trace of execution. And a span is just a lapse of time of a particular execution inside a program. A span has all sorts of metadata to help you understand what is happening. So, for example, this is a capture of a span from the OpenTelemetry website as well, where you can see all the attributes of a span, from the type of platform that's being used by the client, the user agent. There's a few metadata value which are useful to kind of filter and understand the use case of the span, such as server here for the span kind. It can also be internal, or it can be client. So you can this way kind of discriminate between different types of span and kind of make sense of how they're being used. And they have all sorts of this information that is then being compiled together to form a trace, right? This is done by keeping track of your immediate parents or having links to other spans as you go in sequence. So when you put them together, it starts to look like this. And these are two different views of traces interpretation. This is kind of a view where you would look at it from the point of view of inside a program, where you're looking inside the execution of a particular call here to insert a block inside a particular chain. And this is, you talking to the try tree to see exactly how to get the value, going deeper inside the try tree, then running the EVM, trying to do an up call, trying to get the state, et cetera, et cetera. So really getting to the bottom of where the time is being spent inside the program. Very good for all sorts of work around performance. In the same way, you can also map it between different REST services. For example, this is an example that is taken from our documentation at Splunk, where you have multiple services coming together and trying to work out, from a front-end perspective, all the time that is being spent talking to different services. What's interesting here is that we didn't stop just at the service, we went all the way to, let's say, the database, for example. So the database, how much time is being spent working and talking to Redis, working with those different services. And you can see here, there's a little bit of an lapse. It's getting a little too long because when we talk to that payment service, it's getting a little too long. So we're able to map out performance issues and see if there's any errors being reported in red that tell us a bit more about the states in the execution of that trace. Now, when we talk about logs, can keep this comical aspect going. Logs, are well known for this should never happen. This is usually what you see in logs. The problem is that they're curated by humans, so they're only going to be as good as what humans make them, right? When you're a person and you're trying to do the best you can at looking at your particular log, you may think this should never happen, but the code changes, the circumstance changes. It's really difficult for people to be accurate in what they log all the time. So it's half a comment, half an actual instruction. Sometimes people are highly disciplined about this and actually put an error code in their logs, but most of the time that does not happen. And sometimes logs are also used incorrectly, or they're used the best way was possible at the time, such as tracking time, for example, where we're going to just have a system out println here says, so far, migration downtime for collect ID is downtime so far, right? So very clumsy type of logging, very difficult then to make sense of, and then you have to use all sorts of regular expressions to then get the data out. So the good news here is that there are two ways those logs can become more useful all the time. One is we can start metricizing logs, right? So we can see how many times of those occurrences you're seeing this particular log, for example. And then you could start also extracting value out of that log. It becomes even easier if you're using, let's say, Golang with Zaplog in JSON outputs. So, all the fields are being outputted separately. And you can also now associate logs to traces. So new logging frameworks will have the ability to tell you, hey, there's a trace that is currently being recorded as part of the execution of this code. So as you log this, I'm going to add a trace ID and a span ID to this particular log record. When I emit that log record, then you will be able to also say, hey, I'd like to see the execution path of this type of logs, and I can make them come together. So in short, if we standardize on Oli, this is what the web is going to look like. Finally, right? We made it. Awesome. So how do we do that? We adopt OpenTelemetry. OpenTelemetry has this broad mandate, and it's part of the CNCF, the Cloud Native Computing Foundation, to kind of come together and finally standardize all the different aspects of Oli, of observability, right? From tracing, metrics, logs, etc. Having all this stuff figured out. Now, how it works is, again, going back to the specification work that the team has been doing, right? And it's a whole lot of a specification where we talk about codifying logs, codifying traces, codifying metrics, all those things that we may take for granted needed to be kind of rooted into common definitions. What also works is if you're going to use any of the OpenTelemetry agents or SDKs or anything like that, the whole community agreed on environment variables and configuration sets that are going to be the same across the board for all the SDKs all over the place. So all those values, all those limits, all those ways of exporting and importing data are actually now set stable and the same across all components. So if you were to work with a C# program, for example, and you decide to export its traces, you would be using the same environment variables that if you were to use it with a Java program, which allows you then to set a, let's say, Kubernetes set of pods with the same environment variables. And before you know it, all your data is flowing seamlessly to your system, so you can see what is actually going on between all those services. So it's beautiful because it's a gain in time in operations where you may get value out of existing software just by enabling a few environment variables without having to do a whole lot of leverage. So how it works too is using the OpenTelemetry collector. So the OpenTelemetry collector is a product that is published by the OpenTelemetry project, and it's based in a Go program and allows you to then collect all the information from all the different signals and perform actions on them, and then export them to a destination of your choosing. So if you were to deploy inside your environment, you might not want to go straight to the cloud, let's say with your signals. You may want to kind of have a point where you can apply back pressure, check the health, have some level of high availability, these type of things. So you would send all your data here to those receivers So it could be Prometheus data, it could be the native TLP gRPC format that you would expose, let's say, from traces, or it could be Jaeger, which is HTTP based, for example. Those receivers would get all that data. Another example of receivers not featured here is just reading from a file, right, as it's being written to. Then you would batch this data. You would also manipulate the attributes. You could add information such as the host, the Kubernetes cluster, anything you want to kind of characterize the data itself. And then you would maybe process it. So you would be removing sensitive data. You would be able to mask credit card information, these type of things. And then you can send it to a destination you're choosing. Could be any system that accepts this type of data, right? And it could also just be a database or you're choosing or anything like that, or S3 or long-term storage. So this collector is part of your strategy when you start using OpenTelemetry to kind of take care of your data sets and transfer that data to a safe place. So that gives you a whole idea of how it works. Now let's talk about blockchain. And I'm not even the offer, like this is not even my idea. This is coming from Infura, which is a major Ethereum provider of APIs. And if you look at the timestamp, it's coming from 2020, right, in December. So this is from Nicola Cocciario. I'm liberally quoting him here. He is saying that if you use observability, it's monitoring, but then it starts to become more about why. Why is this happening? How this monitoring is impacted, and you want to start looking from monitoring to delve into debugging, to catching failures before they occur, and generate to answer all those questions that we don't know yet we should be asking, but that we will be urgently asking when something goes wrong. So you can see already that there are blockchain providers out there who embraced observability, kind of get an edge in business to kind of have a better operations, so that they can have better coverage of this type of use cases. So I gave a workshop on Besu about 2 weeks ago, 2 weeks plus. I'm going to reprise just a little bit of a few concepts there, so we can talk about exactly where observability plays out. And I'll be somewhat going over some of those concepts. However, if you want to see the workshops available on YouTube, and I have a link at the end of this talk, so you can take a look. So Besu itself is a Ethereum client, which is actually a misnomer. It's actually a server, it's a peer-to-peer agent. It runs a single process. It's independent. So as a blockchain client, it's supposed to go and be able to do everything you would want from a blockchain, right? So it's got all its data. It can perform all exchanges, just sending transactions, receiving transactions, and it can interrogate the chain for you. So you can ask it for the latest block information, transactions in that block. All this information should be available to you because you're running a client and you don't trust anyone, right? So you want to get all the data local to you, checked and validated by your basic client. What that does is that it creates a complex software stack. You're now building a number of network activities, such as the peer-to-peer interface, the RPC interface over HTTP or WebSockets, or even IPC now. You have, if you're doing mining, another network interface for Stratum, and then you may be exporting if stats over WebSockets to a server of your choosing to report your health and your stats. So in effect, Besu works as different components. The first one is it's a database. It's using RocksDB storage. It has multiple stores, and here's why it has multiple stores. It has to store a number of different things. It has to store the blocks, it has to store transactions. It also has to store the try of those transactions, the receipts of those of all the transactions for a particular block, the world state, so the accounts and the view of those accounts. And those accounts themselves have a storage that also need to be stored and has to be cryptographically compliant using a try tree as well. So all this information has to be stored inside the different types of databases, and they all have to be indexed as well, so you can have fast retrieval of that data. And it's all using RocksDB, which is a file-based storage mechanism. Besu is also a transaction pool, so it has a set of activities which consist of receiving transactions in whatever order is being sent or propagated to them. You can send them over JSON-RPC, but you can also propagate them using a gossip protocol based on dev P2P between different clients. That's how your client would take care of it. So if you're not mining yourself, but you send a collection to your client says, yeah, thank you, I cannot do anything with this, but I can probably send it to the rest of the network, and maybe a miner will eventually get that in their pool, and then they'll apply rules to eventually order that into a potential block that will be up for mining with everybody else. And of course, Besu is a network agent, right? So it's completely independent. So of course, configuration, it's going to require a set of truth and few sets to make sure that it's able to communicate with others and check their data. So you never have your client blindly trust what's coming over the network. It's going to get its own Genesis block with its own hash, so it can check that whatever blocks it's getting going forward actually have the right parent hash. It's got its own consensus engine, so it's going to be able to apply some rules about how to validate blocks. It could be that it's using HIFAsh, click, QBFT, all that. And then set of boot nodes to discover other peers, so it's able to connect to other peers in networking and start working. So for example, for discovery, it's using UDP-based messages first to boot nodes, then recursively to other peers to start connecting to more and more peers and fill buckets into Academia table, which is going to be filled with 8 buckets, if I remember correctly, or is it on 256? Yeah, using a distance algorithm based on the inode of a other peer. So here's an inode, right? This is the actual public key of that other peer. It's not compressed using the SCCP 256K1 curve. And then you have here, you have the host, then here you have the TCP port, and here you have the UDP port. So those inodes and those information is what you get in the boot node, or you can also use that as static. And then you can start having all sorts of exchanges like that, where you start getting more and more of those. And then you range them and you try to not be eclipsed attacked by just having a few of them. You want to have as many of them as possible, so you're safe and secure. But it's also a network client, right? So over TCP, you will be embedding your node identity with the public key I just showed you earlier. You will be able to encrypt data that you send to another node and say, hey, this is me, here's me, hello. And then you can negotiate some protocols such as if, other exists, such as Whisper or IBFT, so that you can start exchanging messages. The lifecycle of Hyperledger Besu is you start, you see where you are, you load up your data from your files, you get new blocks from your peers, check whether you're at the top of the chain or not. If you're not, then you start syncing and you reach the head of your canonical chain eventually. And you keep dating new blocks from your peers until you get to the top of the chain, which will then allow you to be into new block, because now you're caught up, so you can check whether the transaction applies or not. If it does apply, then you mint this new block and you give it a parent hash of the latest block you know about, and you can either propagate that block and hopefully you get rewarded for that, or you can get new blocks from your peers and you also propagate them because you want to keep going and you want to keep up with the rest of the network. And you keep going like this, syncing and creating yourself a situation where you want to stay on top of things, so you can keep working through the life cycle of your client. Finally, it's also part of a consensus, right? So you have different organizations that will work together, and so you would want to understand all the aspects of the consortium itself if you're inside an enterprise consortium. In this particular example, and we're going back to that, we have a consortium that is made of people with different clouds, different providers, different set of instrumentations. And so it's important to understand how to work with others, especially when you're trying to have a operator like in the middle, trying to understand exactly how things are going in terms of infrastructure, transaction rate, things like that. The Besu also works as just an RPC server. You can send it a little bit of HTTP like this of a post, or you can use WebSocket, IPC, or there's even a GraphQL API. So it's a complex API server. You can do a number of things. You can batch, you can use it with wallets such as MetaMask directly. And all those options you will want to watch for. So in recap, this is what we're going to go into now. If you're looking at Hyperledger Besu or any blockchain client really out there, you're now working with 4 different softwares come together in a Frankenstein kind of way, where you have a database, a peer-to-peer agent, a queue, and an API server all come together into one single process. So a lot of it can go wrong. A lot of it is intertwined. A lot of it needs to keep up with the latest and greatest. So it's extremely expensive, and it's great for monitoring and tracing. So let's talk about that. If you look at the database and the way Besu is using it, RocksDB metrics make a ton of sense, right? And also what makes sense to understand how the memory is being used. If you're in Java, you have the ability to get all the garbage collection metrics from your JVM metrics. You will also want to understand the writer and indexer tracing. So how much time do we spend in indexing the data that is being stored, and how useful is it? And to be more specific here, we've seen, and I've seen personally, a lot of time being spent by the Besu committers to try to understand exactly all the complex use cases around manipulating the Merkle trees to store them on disk. And then more recently, to also take care of the bonsai data structure. The bonsai data structure is actually cleaning the data over time to avoid having an exponential growth of your tree. But as a result, there are sometimes some interesting edge cases where bonsai might not work. So it's been interesting to see how the debugging goes, and tracing here could be helpful. For an API server, tracing can help you to kind of map it on the service map, like I showed you earlier, right? So you can use HTTP headers, and there are a slew of different standards there that came up that are starting to kind of come together now, right? So you have W3C headers, you have Jaeger headers, you have B3 headers. It's interesting because it can capture the identity of the request, and they can just add a HTTP header for that. But they can also capture the state. So if there's an error, then they can report that as an error. They can report this as the round trip of it. And it's interesting because you can also continue this inside the server. So you can continue looking inside where the time is spent when, let's say, you ask for a block, for example. So that's a question that you might want to ask yourself. Like, if you're running Besu, what's your average latency? Is your JSON-RPC server really spending a lot of time answering questions, and where does it spend its most of its time, right? What's really expensive? Look at it from a point of view of message queue, so debugging your transaction pools, and one of the things that Besu has done for committers have played with is having better metrics. So understanding like, how big is my pool right now? How busy is it? And then you also have the opportunity to trace a transaction by its ID through the pool to a block. So trying to also add to a trace here the transaction ID, so you can then map it and see how often it's being added to a block. For example, is it added often? Is it being discarded? What's going on, right? And then when you do mining with Besu, which is possible, you can also have metrics around solutions or active miners, which is otherwise kind of a blind spot for Besu, right? So you want to know how much activity you're getting on the network, and are you really getting a good set of solutions, or do you have a lot of bad solutions coming from miners? Finally, for syncing, so whenever you get new blocks and all that, having a way to kind of measure the time it takes to insert this new data inside your database is kind of interesting. And for peer-to-peer, that's, I think, the most promising field. We have some metrics already exposed by Besu around peers and peer counts, number of connections, disconnections over time, anything around discovery as well, number of time discovery was ran, etc. But having the ability to also trace messages between Besu clients would be great to understand like who is talking to who, and creating a high-level view of the network itself. And that would be the future of tracing across clients. So here's a quick view of some of the Besu metrics. And sorry, you can see we have different things that actually don't relate to each other. We have a block number here, which is current block number over time. We have the JVM. So we're able to really get a different set of interesting metrics from that view. And also, on the flip side, here's a set of Fabric metrics that we're able to get from the Prometheus metrics exposed by Fabric in the same way. So in this particular case, we can see the transaction rate. We can see the count of endorsal proposal duration. So how much time does it take to endorse? number of entries written. So we're metricizing the logs here, which is cool. We're also metricizing the errors. So we're just counting the number of errors being reported. And we can see the current block number for this Fabric deployment. So on that note, and for Fabric specifically, because I talked about Besu a bunch, we had a RFC opened with the Hyperledger Fabric community for OpenTelemetry, which is voted in and merged into Fabric RFCs. You can take a look here on this GitHub repo. We also have a pull request for Fabric Java chain code that was merged. We can take a look at that with you. So this one is interesting because it's happening inside the chain code itself, right? The chain code is the smart contract, and so instrumenting that smart contract is kind of interesting to kind of understand this. We have some number of OpenTelemetry metrics also that we can enable there, so you can track the state and the metrics as you go about this. And the big thing here is when you invoke, this creates a particular span that is going to execute around the execution of your actual chain code execution stub, right? So when you invoke your stub, we already created an environment for you to start reporting the state and the value of that. What that does for you is that it gives you a trace every time your chain code executes. So if you're able to configure your chain code execution to report traces, then you can see light up in your environments, in your tracing environments, the traces of every time of those invocations, the results of those invocations. For example, here, if we see an error, then we'll be able to report that, and then we'll be able to tell you on average how much of the time it works, and sometimes when it does not, right? And you'll be able then to also report if it's ending. You can see the latency of your execution. So this was an easy kind of add to that execution framework, but also we started looking at adding gRPC interceptors in Fabric itself. So Fabric is using gRPC to have the ability to communicate between peers and between different elements. So there's a number of interceptors which are here already. And so what we did is we just added it in the OpenTelemetry Go SDK. We have the ability to add interceptors, which add additional headers to the gRPC message. And so by adding those, we can then actually understand the propagation of messages inside this distributed system. Then if we report those traces, we'll be able to very easily create a service map of your Fabric cluster. So this is in progress because it takes a little bit of time to get the kinks out, get the community also mobilized around this. And this is something I'll talk about if I have time at the end around the next step on that. For Besu, well, I'm a committee on Besu, so I could go a little further. We have a little bit of an update on that, documentation, sorry, on that with an OpenTelemetry page, and you can just enable OpenTelemetry using matrix enabled, and matrix protocol equals OpenTelemetry. You can use Splunk, you can use others to kind of visualize all the collected data. And we have an example of how to configure a connector to get all this data and send it to the Splunk, for example, here. Right. How it works is we have an OpenTelemetry system, which is a type of metric system that is being exposed here, that actually creates an OpenTelemetry and an SDK provider that is going to report on a periodical basis to an endpoint of your choosing that is being configured as part of your environment variable, and also has the ability to get all the data. This is meant to be interchangeable between the Prometheus metrics provider or OpenTelemetry metrics provider. So a couple more examples. In the JSON-RPC service, for example, we have the ability to create a span around any execution of any JSON-RPC method. In that case, we create a server span where we give it an address of the host and port that is calling you. We give it a parent if there's such a parent as, it could be extracted. And then we start the span with that. Once the execution of vertex is done for this particular method, we either record the exception and we make it an error, or we just end it. So what happens there is that we also, in that particular context, add headers to the response. So you're able to say, oh, okay, I'm talking to Besu, this is what it looks like. And I'm able to, if there are any request attributes, such as the trace ID on the request that is incoming to the JSON-RPC port, map it to an existing trace, record that as a parent. So we can actually correlate this trace to any other trace from the system that is talking to Besu. And a fun one is pipeline. Pipeline is used to sync and to perform batch actions on the back end of Besu. So for this particular one, we try to create a generic span that we're going to use to trace the activity of a pipeline. And so we can actually see when we run this, the syncing activity of Besu, and we can see where it spends its time inside this, right? So the task span itself is started here. If there's any issue whatsoever, we'll mark it as an error, of course, and then we'll end it at the end. What's interesting is to, eventually pass it down into more specific items. But we can do that using auto-instrumentation for RocksDB, for example, so we don't have to do as much manual work to give it all this metadata. Okay. So, so the interesting part here is that I talked a little bit about the interconnectivity between all those clients, and we have trust and no trust scenarios, right? So if you trust everybody in your consortium, you would be able to just have everybody send all the data to one place. And then from that place, the operator could look at all the traces, all the metrics, and actually make sense of what is going on and help you proactively fix your systems or debug why one of the actors did not get metrics or traces in time. But if there's no trust, you can also choose to only share some of the data. And this is what's happening here. We see different tiers. You can see only some of the logs. You can see only some of the metrics. You can just see the organization ID and a little bit of them, right? So this allows a consortium to kind of create a health dashboard for themselves, where they can really see how it's faring and whether there's any data that needs to be corrected and brought to the operators of the consortium. So let's talk about the future and bright future, low apocalyptic maybe. Okay, sorry about that. So the future for me, and this is my view of it, is that we're going to see new types of activities and actions which are going to be enabled by a combination of observability and blockchain. I'm going to delve into 3 different types. The first one is, I see it as trace central. I just talked about trust and no trust scenarios. I believe that in the future, you will always be on the subway RAM executing and performing actions, and you won't have time to operate a monitoring or debugging system. So you'll start working with actors that will dedicate themselves to get all your signals, be it metrics, traces, even your logs, and start proactively reporting to you issues, which means that you will have a lot less in terms of work to do to keep up with the state of your network. And you'll be able to go much faster to destination using this approach. And even better, then you can coordinate all your separate RAMs between each other so there's no crashes, right? And this type of collaboration and coordinations will become more and more common over time. And what would be great is if we talk all the same language, and we start to standardize on this type of technologies, and we can really go quickly to kind of create those consortium level activities. So I see that happening already with our existing Splunk offerings, for example, with our existing customers. The other thing that really excites me is I want people to start being able to use systems for free. Let's say you have a voting website, for example, and you're a user here. You have your secrets, you're performing actions on the website, and you're kind of left to your own devices. A would be a free website for users to use, and even for you to set up a vote, for example. And if you want to get insights in terms of metrics and traces, then you would pay more money to get additional data. And the kicker here is that this website, this SaaS provider, would not need to build all the dashboard and all the backend of showing you all the activity of those users, which is a pretty extensive and proprietary task right now. Instead, if they were to allow you to download a feed of all those metrics and traces, then you can create your own dashboards using your own solution that allows you to actually make sense of what's going on the website. It's less work for the SaaS provider. It's more control for you, because then you can swap between different providers and you can keep using your own dashboards for your own use cases. And you keep your IP to yourself, in the sense of the dashboard you create becomes very specific to the use case that you have of leveraging the website for your activities. And finally, trust providers. So signing traces, checking the execution of a particular trace. If you work with a provider, and let's say you work with a major commercial entity and you're sending them an invoice, then you will be able to see how the invoice is progressing through the system by checking traces, right? And if they sign the trace, then you can for sure know that they're executing that in good faith and then trying to go about your invoice in the right way. If you can do that, then you can also use all sorts of newfangled technology, such as zero-knowledge proof, to see if, without sharing data, you can verify that the system is processing your claim and going about your execution correctly. So I like this particular person on Twitter, because I always ask open-ended questions like this, and they get some pretty good insights from different people. The gist of that discussion seems to be, it's not yet a thing. It's not yet happening. We're not yet using zero-knowledge proof to provide trust in execution of other programs. But I can see the conversions happening between observability and zero-knowledge execution. So further reading, infra on observability. Here's a website blog post that I showed you earlier. We also have a blog post on Besu on the Splunk.com website, on Hyperledger being an observability pioneer. And I kind of punted a little bit on our workshop. We have a 4-hour workshop on YouTube you can watch, and you can learn to extend Besu. It's pretty awesome. So if you want to read more, that's interesting there. Okay, so I talked a lot, and I can't wait to hear from you all. I'd love to hear your questions.
Yeah, thank you very much, Antoine. It was a really great and dynamic presentation, and I really liked your analogies, with the subway map or the lock. And so to everybody joining us, please raise your hand and ask any questions you may have, or use the Q&A box. We still have a couple of minutes left, so we can still address those questions. Okay. Doesn't seem to be any open questions, Antoine?
No worries. So I'm going to give you a couple of indications where to find me and how to work with me if you're interested in this. And you happen to be listening to this on YouTube in a couple of weeks, and you're wondering, well, that's great, but really, what's in it for me and how do I participate in this? So the Hyperledger Foundation is interested in getting better at how to execute on this particular agenda. I see Anna just raised her hand. I'm just going to finish this quickly. There is definitely going forward an agenda to work on this as a community with Hyperledger. And I received some interest from people. There's on one PR, there's a few folks that reached out to me. We're going to create a task force with Hyperledger to kind of discuss how we want to go about this in a more consolidated way, especially for Fabric. And I hope that we will be able to then quickly iterate on this and create all sorts of interesting technology sets for this. So it will be on Discord. There'll be a channel for that, and there's a task force group And if you're interested, chime in. I get a question.
Yeah. Antoine, I was wondering, using OpenTelemetry and Besu, I could like get traces to see how information is going on different nodes from, well, you know, it's like I work for one of the companies inside the blockchain. I'm not going to check on every other one, it's only mine, but maybe I need to know how the others are getting my information. I'm not sure if you get,
Yeah, so, and this is, I think this is crucial to distributed systems, and this is where I think we have to kind of keep innovating on this. If you go back to this diagram, which is a thing we use to kind of represent the scenario, let's say you're org number 3, right? You're working in your Azure environment and you're only sharing some of this information. You would be able to keep your own information because you want to operate your own cluster. You don't want to talk to anyone else. Maybe you just want to know. But as is well known with blockchain, right? In distributed systems, it's the only type of system where another machine you don't know anything about can break your system, right? So let's say org number 1 starts to mess up with its own metrics and their system is down, their host is no longer available. You want to know about this and vice versa, right? So you would be able to come to an agreement where you would share voluntarily some of the data, maybe not all of it, and you would be able to then create a dashboard which would give you a view of all the participants at this level. So this is actually a dashboard from Splunk. If it's using searches around the data that is being shared by consortium members to kind of update dynamically, and it's kind of gimmicky, but bear with me for the example, to kind of update, say, okay, here actually means I'm getting data from that particular org, right? This data did not choose to share its data around its consortium, so it's going to be checked as no. So you can check here. You can see at the top level, right? Data health is okay. We're getting the logs. Blockchain health, we're getting collections. We're getting blocks. Everything is working as it should. Infrastructure health, well, we have to check. This Azure environment here starting to report issues. Sorry, yeah, it's reporting issues now. Okay, so it's reporting data, but it's showing issues. So hopefully what we'll be able to do is we can create OpenTelemetry collector scenarios where you can route the data to your own. You can also route the data, and some of it only, to a central OpenTelemetry set of collectors that will give you a view of everything at once. And we have examples that showcase that you can use to kind of make sense. I'm actually, a little bit on the spot, but I can show you that. So we have under our signal FX org, under Splunk Hotel Collector, we have an example here that shows you hotel logs routing, which I built. And it's kind of interesting because it's showing a first hotel collector, which is going to talk straight to Splunk, and the second hotel collector, which is going to be routing some of the data only from this file log, listening to the file, and then sends to another hotel collector, which could also choose to go to another entity. Could be going to Splunk, could be going to another Splunk, could be going to a provider of your choosing. Well, what's awesome, and what, as a big an open source advocate, this hotel collectors, this OpenTelemetry thing is all Apache licensed. So it does not need to change based on your provider. It could be that you use Splunk today, you want to use a different provider tomorrow. It still works the same way. It's good, it's standard, it's helpful, it's a good investment into your future as a company to be able to operate and monitor and debug what's going on.
Great, thank you.
You're welcome. Hopefully this was helpful. I see a comment from Todd. Thanks, Todd. Appreciate your comments. Todd's saying I did a good job.
Yeah. Thanks again, Antoine. I think we'll need to wrap it up. We're almost at the top of the hour. And thank you, Anna, for your question, and Todd for your comment as well. So as Antoine said, if you're watching this a couple of weeks from now on YouTube, you are very welcome to reach out to us or Antoine, and the slides will be available there as well in our webinar library. So you can always check this one out and also reach out to us. So thanks again, Antoine. You covered such a lot of useful information. It was really a great presentation, and thank you for your time. So as mentioned, and also as Antoine mentioned, we do have our Discord channel, and just let me share my screen. There we go. So here you are very welcome to join our Discord community and explore these channels related to Hyperledger projects like Fabric and Besu that Antoine was presenting, but also special interest groups, working groups, our regional chapters, and much more. And you can find the topics that are of interest to you. Also, Hyperledger Global Forum is happening in Dublin, Ireland from September 12th to 14th, and it will be a great opportunity to meet in person as well. Now, thank you everybody for watching. Thank you, Antoine, and thank you everybody for joining us and for all of the great questions. And if you have anything additional, please feel free to reach out to us and we will be able to help. Thank you, everybody, and have a nice day.
Bye.
Bye.